Okay, in this particular channel, I will be solving some likely questions. In this particular channel, I will be solving some likely questions. Now, in this particular question, they give the information provided. They told us in this question that this is solution of hydrogen chloride. This is solution of hydrogen chloride. That means our D is the what? Acid. This is solution of what? Hydrogen chloride. D is the acid. And they can also decide to ask you in your question when performing your titration experiment, your acid is placed where? Your acid is actually being put in the what? In the burette. Your burette occupies the what? Acid. And in this question, they said E is a solution of S2CO3. E is another solution. E is the base. And the name of the base in this particular question is what? S2CO3. And your base is always placed inside the conical flask when you are performing your titration experiment. In this particular question, they gave us the information. They said D is a solution of HCl containing 7.30 gram per dm cube. Automatically, they've given us the what? Mass comp of D. Mass comp of D. In this particular question, the first thing you will do is to state your parameters. Mass comp of D has been provided, which is what? 7.30 gram per dm cube. You state your parameters. Mass comp of D has been provided. Now the next question is, how do I know that 7.30 is the mass comp? Now we have two types of concentration. Number one, molar concentration, and number two, mass concentration. For molar concentration, the unit is what? Mole per dm cube. Molar concentration, the unit of molar concentration is mole per dm cube, while that of mass concentration is gram per dm cube. Anytime you see a particular unit or a particular value measured in gram per dm cube, that means that particular value represents mass comp. Now for E2, they gave us the mass comp of E to be 10.6 gram per dm cube. Mass comp of E was also given in this question. Mass comp of E is 10.6 gram per dm cube. 10.6 gram per dm cube was also provided. The mass comp of E was also provided, 10.6 gram per dm cube. They now said put D into the burette and titrate against 25 centimeter cube of E. That means in this question, they've given us the volume of E. This is the volume of E that we are titrating. Volume of E. Volume of E has been given in this question. The volume of E is 25.00 centimeter cube. When you are given questions like this, the first thing is to state the parameters of the information given. In this particular question, D is representing D is standing for our acid, while E is representing the what? The base. The acid in this question is represented with letter D. The acid in this question is represented with what? Letter D, while the base in this question is represented with what? Letter E. The acid in this question is hydrogen chloride, while the base in this question is S2CO3. They provided us with the mass comp of the acid to be 7.30, and they also gave us the mass comp of the base to be 10.6 gram per dm cube. And in this question again, they gave us the volume of the base to be what? 25.00 centimeter cube. And apart from that, they also gave us the equation of reaction. From the equation of reaction, we can determine two things. From the equation of reaction, your equation of reaction is the representation showing how the acid and the base are reacting together. This is the base, this is the acid, forming the salt, water and CO2. Remember that anytime acid reacts with carbon 4, it will always form salt, water and CO2. In this particular reaction, we are looking at the mole ratio between the base and the acid. The mole ratio of the base is 1 because there is no number at the back of the base. The mole ratio of the base, the numbers of mole of E is 1, while the numbers of mole of the acid is 2, the number at the front. the numbers of mole of the acid, numbers of mole of D is our acid, it is 2. That is the information provided. The numbers of mole of the base, there is no number 1. While the numbers of mole of the acid, the number at the front of the acid is standing for the what? The mole. That means the ratio of the acid to base in this particular question is what? 2:1. The ratio of the acid, to the ratio of the base is what? 2:1 in this particular question. Now let's look at this question carefully again. E now said from your result and information provided, calculate the average titral value of the acid. The question number 1, they ask us to calculate the average titral value of the acid. Now question number 1, average titral value of the acid. Average titral value. Remember that this is alternative to practical. You are not performing the experiment. The average titral value of acid. Average titral value of acid. Remember that this is alternative to practical. You are now performing the experiment. In this particular question, the table has been provided. From the table provided, they ask you to calculate the what? Average titral value. Now, for you to calculate your average titral value, you look at the readings that are what? Consistent. You look at the what? The readings that are what? Consistent. In this particular experiment, they gave us the titration number. This is the first titral value, this is the second titral value, and this is the third titral value. Now, for you to get the volume of acid used, the volume of acid used is your what? Final burette reading minus what? Initial burette reading. That's how I arrive at what? 25.50. The volume of acid in this particular question again is 27.50 minus 2.45. That's how I arrived at what? 25.05. In case the acid will fill in the gap. Now, for the third one, the final burette reading is 25.65, while the initial burette reading is what? 0.50. 25.65 minus 0.50 will give us what? 25.15. But according to the question, they ask us to calculate the what? Average titral value. For us to calculate the average titral value, we look at the volume of acid. After looking at the volume of acid, we look at the value that is actually what? Consistent. We look at the volume of acid. We look at these values. We look at the volume of acid. These are the volumes of acid. We have 3 volumes of acid: 25.50, 25.05, and 25.15. But in this particular question, we will do our what is called comparison. We look at them to see the value that is actually consistent. When is a value said to be consistent? A value is said to be consistent when the difference between them is lesser than or equals to what? 0.20. Now when we look at these two readings, 25.50 minus 25.05, the difference between them is what? 0.45. Because of that, these two readings are not what? Consistent. They are not consistent. But when you look at this 25.15 minus 25.05, the difference between them is what? Is 0.10. Because of that, these two readings are consistent. Remember that a reading is said to be consistent when the difference is lesser than or equals to what? 0.20. Automatically, my average titral value will now be my second titral plus third titral divided by 2. My second titral, which is what? 25.05, and my third titral, which is what? 25.15 divided by 2. 25.05 plus 25.15 is what? 25. 25. Give me the answer for the upper one. 25.05 plus 50.2. 50.20 divided by 2.
25.1.
It will now be what? The average titral value will now be 25.10 centimeter cube. 25.10 centimeter cube. My average titral value is the second plus third divided by 2. 25.05 plus 25.15. The answer is 50.20 divided by 2. The answer happens to be what? 25.10 centimeter cube. That means the volume of my acid Vd, volume of my acid will now be 25.10 centimeter cube. Now the next question is state the indicator used in this particular titration experiment and why. The next question state the indicator used and why. Now in this particular experiment our acid happens to be hydrogen chloride, which happens to be a strong acid, and our base happens to be S2CO3, which happens to be a what? A weak base. And remember that if the titration experiment involve a strong acid and a weak base, the indicator that will be suitable for the experiment will be what? Metiorange. Metiorange. And why? Because it is between strong acid and a weak base. Question 2 has been answered. Let's move to the third one. Concentration of D in mole per dm cube. Concentration of D in mole per dm cube. We ask us to calculate the concentration of D in mole per dm cube. In mole per dm cube. They ask us to calculate the concentration of D in mole per dm cube. That's what they ask us to look for in this question. Concentration of D in mole per dm cube. Now, since they ask us to look for the concentration of D in mole per dm cube, concentration of D in mole per dm cube will be the mass conc of D over what? Molar mass of D. Concentration of D in mole per dm cube will be mass conc of D, molar concentration of D, molar conc of D will be mass conc of D over molar mass of D. Mass conc of D over molar mass of what? D. They ask us to look for the molar conc of D in mole per dm cube. Now we are looking for the molar conc, we don't know, but the mass conc of D has been provided 7.30. The mass conc of D, the mass conc of D has been given in the question. Mass conc of D is what? 7.30 gram per dm cube. Now the next thing I want to do is to look for the molar mass of D. Molar mass of D. The name of the compound D happens to be what? Hydrogen chloride. Hydrogen chloride. Compound D happens to be hydrogen chloride. I want to look for the molar mass. 1 times 1. Relative atomic mass of hydrogen is 1. And we have 1 atom of chlorine. Relative atomic mass of chlorine is 35.5. 1 times 1 is 1 plus 35.5, which is what? 36.5 gram per what? Mole. That's the unit of molar mass. Molar mass, the unit of molar mass is what? Gram per what? Mole. I am looking for the molar conc of D. The mass conc of D has been given 7.30 gram per dm cube. Why the molar mass of D? We've gotten the molar mass of D to be 36.5 gram per mole. That means 7.30 divided by 36.5 is 0.2 what? Is 0.2. Is that the final answer? 0.2. 0.2 mole per dm cube. 0.2 mole per dm cube. Now remember, when I was calculating the molar conc of D, molar conc of D, memorize this formula. Molar conc of D is mass conc of D over molar mass of D. In this question, they provided us with the mass conc of D, 7.30 gram per dm cube. Now, and they've given us the name of the compound D. D happens to be our acid, which is what? Hydrogen chloride. The next thing is to look for the what? Molar mass of what? Hydrogen chloride. And the molar mass of hydrogen chloride happens to be what? 36.5. Mass conc of D 7.30. Molar mass of D 36.5. After dividing, we got 0.2 mole per dm cube. 0.2 mole per dm cube. Now the fourth question, they ask us to calculate the concentration of E in mole per dm cube. In this question, they ask us to calculate the molar count of E. In this question, they have asked us to calculate the what? Molar count of E in mole per dm cube. They ask us to calculate the molar count of E in mole per dm cube. Now, since we already know the molar concentration of the acid, the molar concentration of acid, we've gotten the molar concentration of the acid in question number 3. They now ask us to calculate the molar concentration of the base, which happens to be E in mole per dm cube. Remember that we are expected to make use of this formula when one of the concentration is known. We are expected to make use of this formula when one of the concentration is known. Now, in this particular question, the concentration of D has been given to us, and they ask us to look for the concentration of E. We are only expected to use this formula if one of the two concentration has been given to us. I was unable to make use of this formula when solving question number 3 because in question number 3 we don't know any of the concentration. We don't know the two concentration was not provided. That is why I could not make use of this formula when solving question number 3. But we can only make use of this formula when one of the concentration is known. Once they provided you with the concentration of the acid or the concentration of the base, you don't need to waste time. Make use of this particular formula to solve for the other concentration. In this question, they ask us to look for concentration of E, which I don't know, question mark. Volume of E has been provided in this question, 25.00. Numbers of mole of D has been provided, numbers of mole of E has been provided in the question. From the equation of reaction, we get the numbers of mole of E, which happens to be 1. Numbers of mole of D can also be gotten from the equation of reaction, which happens to be 2. Volume of D is our average titral value, which happens to be 25.10 centimeter cube. Now the next one, concentration of D. From question number 3, our concentration of D happens to be 0.2 mole per dm cube. Now, you are expected to make use of this formula when one of the concentration is known. We are looking for concentration of E. We know the concentration of the acid, which is 0.2 mole per dm cube. The next thing is to make E subject of formula. Concentration of E subject of formula. It will now be CD, which is concentration of the acid times volume of the acid times numbers of mole of the base over volume of the base times numbers of mole of the acid. Your concentration of E will now be concentration of D is 0.2, volume of acid 25.10, numbers of base 1, volume of base 25.00, and numbers of acid 2. Remember that E represents base while D represents acid. 0.2 times 25.10 is what?
0.1.
0.1. 25 times 2 is what? 50. 0.1 divided by 50 is what?
0.1.
0.2 times 25.10 times 1 is what?
5.02.
5.02. The upper side is 5.02. While the down 25 times 2 is what? 50. 5.02 divided by 50 is what?
0.1.
0.1. 0.1 mole per dm³. So therefore, the concentration of our base is 0.1 mole per dm³. The concentration of the base is 0.1 mole per dm³. I will be solving the last question now. Molar mass of S2CO3. Molar mass of S2CO3. Now the next one I will be solving is the fifth question. In this particular question, they ask us to calculate the molar mass of S2CO3. Molar mass of S2CO3. That's what we are looking for. Molar mass of S2CO3 unknown. Molar mass of S2CO3. Now in this particular question, information that are related to E that was actually provided in this question. In this question, they giving us the what? The mass form of E. Mass count of E has been provided in this question. Mass count of E has been provided in this question to be 10.6 gram per dm³. The mass count of E has been provided in this question. Now, from our calculation of question number 4, we've gotten the molar count of E. We've gotten the molar count of E to be 0.1 mole per dm³. And remember that molar count of E is equals to mass count of E over molar mass of E. Remember that molar count of E is mass count of E over molar mass of what? E. The next thing I need to do, since I have two known, I'm just looking for what? Molar mass. The molar count of E, we know it to be what? 0.1 mole per dm³. And the mass count of E has been provided in the question to be 10.6 gram per dm³. The only thing I need to do here is to make what? Molar mass of E subject of what? Formula. That means molar mass of E times molar count of E equals to mass count of E. Now, I will divide both sides by what? Molar count of E. Molar count will cancel molar count automatically. So therefore, molar mass of E will now be mass count of E over molar count of E. Mass count of E is 10.6, while the molar count of E is 0.1. 10.6 divided by 0.1 is what?
106.
106. That means the molar mass will now be 106 gram per mole. 106 gram per mole. 106 gram per mole. In the subsequent videos, we'll be looking at some of the likely questions to be expected in your next examination. Kindly click on the notification button, make use of the comment section in order to ask questions that are very important on this particular practical section.